So the first rule is called the product of powers, and it says if two powers with the same base are multiplied, you can add the exponents. Okay, so if we try number 1a, 10 to the third times 10 to the 8th, we add those exponents, that's 10 to the 11th. b, 7 to the third times 7 to the 5th would be 7 to the 8th power. c, x to the 11th times x to the 9th, again, same base, so we can add the exponents, that's x to the 20th. And d, 6/4 times 6 to the 2nd would be 6 to the 6th power. Our second rule is called the quotient of powers, and that says if you divide two powers with the same base, you simply subtract their exponents. So in number 2a, we have 11 to the 7th over 11 squared, or divided by 11 squared. So we keep the base, which is 11, and subtract the exponent. 7 minus 2 is 5. Part B, 8 to the 4th over 8 to the 3rd would be 8 to the 4 minus 3, which is 1, or that's simply 8. Part C, y to the 8th divided by y to the 5th. You would subtract the exponents, come up with y to the 3rd. And part D, 5 to the 9th divided by 5 to the 4th. When we subtract exponents, that's 5 to the 5th. Okay, number 3, this rule is a power to a power, which says if you have a power raised to another exponent, you simply multiply the exponents and write it as a single power. So in part A, 4 to the 7th raised to the 3rd power, we multiply the 7 times the 3, and that's 4 to the 21st. Part B, 13 squared raised to the 4th would become 13 to the 8th. In part C, r to the 8th raised to the 5th power, r to the 40th. Lastly, part D, 10 to the 6th squared becomes 10 to the 12th power. Okay, this should actually say number 4, but this rule here is probably the one that would seem the newest or the most confusing, and that is just saying that a negative exponent can be rewritten as a fractional power, where you just take the base, put it into the denominator, and change your negative exponent to positive. Okay? That also works the other way. If you start with a fraction with the power in the denominator, to get that power out of the denominator, you simply move it up into the numerator, but change the exponent to its opposite sign. Okay? So an example of that would be part A, 1 over 7 to the 6th. To get that power out of the denominator, I simply change the exponent 6 to its opposite, so it's 7 to the negative 6th. Part B, which is 1 over x to the 4th. To get the x to the 4th out of the denominator, I write it as x to the negative 4th. And going the other way, in part C, if I start with 10 to the negative 8th, to change that into a positive exponent, it must become 1 over 10 to the positive 8. All right, so a little review here of each of those rules. And the key in the directions here is our answer should always be in the form of 2 with an exponent. So part A, 2 to the 7th times 2 to the 5th. Since we're multiplying powers, we add exponents. That's 2 to the 12th. Part B, 2 to the 11th over 2 to the 8th. That's division. So we subtract exponents. That's 2 to the 3rd. Part C, power to a power. We're going to multiply the exponents. So 2 to the 36th power. Part D, 2 to the 3rd divided by 2 to the 10th. So I need to subtract the exponents, and I get 2 to the negative 7th. Now, another way to write that is 1 over 2 to the positive 7th. But because these directions say we want to write it in the form 2 raised to a power, I'm going to keep it with a negative exponent. Okay, part E, same thing. I need to go back to the directions and think about what that means. 4 is 4 to the first. Nothing wrong with that, but to write it as an exponent, as a power of 2, we write 2 to the second. 2 squared is 4. 32 is 2 to the 5th power. Now, in 1 over 8, since 8 itself is 2 to the 3rd, this being in a fraction, I'm going to write that as 1 over 2 to the 3rd. But once again, because I need this in the form of 2 raised to a power, I need to change that into 2 to the negative 3rd. And I'm going to do that same thing in part H with 1 over 16. Since 16 is 2 to the 4th, this is technically 1 over 2 to the 4th, which I will write as 2 to the negative 4th. All right, now I'm just going to go through some more examples just for extra practice here. Okay, so in this first one, number 1, that y doesn't appear to have an exponent. Anytime there's no exponent written, it's automatically a 1, not a 0. So y to the 1st times y to the 5th, I'm adding those exponents, that's y to the 6th power. Number 2, again, multiplying powers, so I add the exponents, that's n to the 9th. Number 3, now there's a coefficient in front of the x squared. That doesn't bother us. We just leave the negative 7 right where it is, and we use our product of powers rule to multiply x squared times x to the 4th. Adding those exponents, that's x to the 6th. Number 4, I have 3 powers multiplied. Remember, this is x to the 1st. I just add all 3 exponents. 1 plus 2 plus 4 is 7. So this is x to the 7th. Number 5, m to the 1st times m to the 5th, become m to the 6th. Number 6, since I'm multiplying 2 negative powers, a negative times a negative, this negative times this negative would turn into a positive answer, and then I simply add the exponents. This is x to the 7th. Number 7, now we have coefficients in front of both powers. This 8a is really 8a to the 1st. Now don't try to use your exponent rules to combine the 2 and the 8. Okay, that is just 2 times 8, which is 16. Now I use the exponent rules only for the powers. A squared times a to the 1st would be a to the 3rd. Okay, and number 8, I can consider the r's and the s's separate. So this is r to the 1st, s to the 1st. The next power is r to the 1st, s to the 3rd. And the last one simply s squared. So when I multiply here, I will put together the powers that share a base. So r to the 1st times r, another r to the 1st is r to the 2nd. Now, s first times s third times s squared, 1 plus 3 plus 2 is 6. So that's s to the 6th. Number 9, I have one coefficient, which is a 4. Nothing to multiply that with in front of the other power. So 4, now x squared times x to the 1st is x to the 3rd. Here's y to the 1st times y to the 3rd, y to the 4th. Okay. Number 10, I can multiply all of the coefficients, all of the constants here. So 1/3 times 2 times 6. Well, 2 times 6 is 12. A third of that is 4. A to the 3rd, I don't have any other powers with an a as the base, so I have to keep that a to the 3rd. but then I have b to the first times b third, which is b to the fourth. Number 11, I have a negative times another negative, so this will be a positive answer. 4 times 5 is 20. X to the third times x to the seventh. I add those exponents, get x to the 10th. Number 12, negative 3 times 2 is 6. J squared times j to the first would become j to the third. K to the fourth times k to the sixth. I add those exponents, get k to the 10th. Number 13, multiplying the coefficients 5 times 1/5 is 1. A squared times a to the first is a to the third. B to the first times another b to the first is b squared. And c to the third times c to the fourth, adding those exponents, c to the seventh. Now, I don't need to write this 1. I could also write this as just a to the third power, b squared, c to the seventh. Number 14, again, multiply my coefficients. Negative 5 times 4 is negative 20. X first times x squared is x to the third. Y first times y to the fourth is y to the fifth. And the last one here on this page, number 15, 10 times negative 2 is negative 20. X to the third times x is x to the fourth. Y to the first times y to the fifth would become y to the sixth. Z squared times z to the first is z to the third. All right, so on another set of practice problems here, we're going to raise a power to a power in number 1, so y to the fifth squared. We multiply those exponents, that's y to the 10th. Number 2, n to the 7th raised to the 4th is n to the 28th. Now, number 3, I'm going to use a couple of rules. First, I need to apply the power to a power rule. So x squared raised to the 5th becomes x to the 10th. But then I'm multiplying by x to the 3rd. So in the end, this becomes x to the 13th. So first, power to a power told me to multiply. But then the product of powers says same bases, add the exponents. So 10 plus 3, 13. Okay, and number 4, that negative 3 is not inside the parentheses, so it does not have an exponent on it. This 3 out here only applies to what is inside the parentheses. So I'm going to leave the negative 3 in front. This power of 3 applies to the a and to the b to the 4th. And when I say applies, we need to use our power to a power rule. So a to the first to the third, multiply 1 times 3, that's a to the third. B to the 4th raised to the third, multiply those exponents, that's b to the 12th. And that cannot be simplified any further. Now, the difference between number 4 and number 5 is now the negative 3 is included in the parentheses. So it also gets the exponent applied to it. So this is negative 3 to the third power. Now, I have to put the negative 3 in another set of parentheses in order to say the negative sign is also included with the exponent. It gets the exponent also. This is a to the first to the third, so a to the third. B to the 4th gets raised to the third, that's b to the 12th. Now, one other way to write this, negative 3 times negative 3 times negative 3 would be negative 27, a to the third, b to the 12th. Number 6, again, the 4 is inside the parentheses, so it gets the exponent. So 4 to the third, x to the 6th, b to the third. Or if we multiply that out, 4 times 4 times 4 is 64, x to the 6th, b to the third. Number 7, Again, we're going to have to use a couple of rules here. First, we have to do the power to a power rule. So that's 4 squared a to the 4th. And then we're going to multiply that by b to the 3rd. Now, since there's no common basis here, we can't simplify that anymore other than to possibly say we can call that 4 squared 16 a to the 4th, b to the 3rd. So either of those answers. Number 8, apply the power to a power. So 4 squared x squared b to the 3rd, or once again 16 x squared b to the 3rd. Number 9, power to a power. 5 applies to both of the powers inside, so that's x to the 10th, y to the 20th. Number 10, now this exponent of 2 out here only goes with the b to the 3rd. So 2a to the 3rd b squared, I won't do anything with that yet, times b to the 6th. Now since I do have 2 powers here with the same base, I can simplify that further and say that's 2a to the 3rd b to the 8th. Number 11, okay, I'm going to have to use power to a power and then the product of powers. So let's first work in this first parentheses with the exponent of 3 behind it. Now that goes with everything inside, including the negative sign. So negative 4 to the 3rd, x to the 3rd, y to the 3rd, times, and we do the same thing with the second parentheses, that exponent of 3 goes with everything. So negative 2 to the 3rd, x to the 6th. Now, I need to combine the x to the 3rd with the x to the 6th using my product of powers rule. That becomes x to the 9th. The y to the 3rd can't be combined with anything else. But these 2 powers, the negative 4 to the 3rd, negative 2 to the 3rd, I can either leave them separate, or if I multiply them out, negative 4 to the 3rd is negative 64. Negative 2 to the 3rd is negative 8. So that would be, when I multiply negative 64 times negative 8, that would be positive, let's see, 64 times 8, 512 x to the 9th, y to the 3rd. Number 12, very similar to number 11. We need negative 3 squared j to the 4th, k to the 6th, times 2 to the 3rd, j to the 6th, k to the 3rd. Notice I can put this negative 3 in parentheses because it was a negative number being raised to a power, but I didn't have to do that with the 2 to the 3rd because it's positive. So what needs to be combined here are the j's. So j to the 4 plus 6 is 10, and the k's, k to the 6th times k to the 3rd is k to the 9th. But like we did in number 11, we could either keep these powers, negative 3 squared times 2 to the 3rd, we could keep them separate, or if we simplify them, negative 3 squared is 9, 2 to the 3rd is 8, so 9 times 8 is 72. So 72 j to the 10th, k to the 9th. Okay, number 13. We have to apply the power to a power first. So 25 to the 3rd power, a to the 6th, b to the 3rd, times 1/5 squared a squared, b squared, c squared. Now notice I had to include that 1/5 in parentheses, much like I had to do with negative bases in number 11 and 12, because putting it in parentheses indicates that that exponent is applied to both the top, the numerator, and the denominator. Okay, so I can simplify the a's a to the 6th times a squared is a to the 8th. B to the 3rd times b squared is b to the 5th. And then the c squared has to stay the way it is. And I can either leave this 25 to the 3rd times 1/5 squared, or I could simplify that. Now, 25 to the 3rd is 15,625. 1 over 5 is 1/25. So when I multiply those, it simplifies to 625. A to the 8th, b to the 5th, c squared. Okay, number 14. The 2, this first exponent, is applied to everything in that first parenthesis, so 2 squared, x squared, y squared. There's no exponent on either of the next two parentheses, so I can just recopy them here at this step, or if I want to go ahead and multiply those together now, I could do that. Negative 3 times 4 is negative 12. X squared, y to the 4th can't be simplified any further. And now I multiply these two parts. So 2 squared is actually 4 times negative 12 is negative 48. X squared times x squared is x to the 4th. Y squared times y to the 4th is y to the 6th. Number 15. 2 to the 3rd power, x to the 9th power, y to the 6th power, z to the 6th power. In the second parentheses, x to the 8th, z to the 4th. What can be combined here? I can leave 2 to the 3rd as is, or I could change it to 8. X to the 9th times x to the 8th is x to the 17th. Y 6th has no other common basis to combine with it. Z 6th times z 4th is z to the 10th. So the only other way to write that would be 8 x 17th, y 6th, z 10th. Okay, number 16. The only power to a power here is at the end, so this will become n to the 3rd, y to the 3rd. But I can go ahead and multiply these first two powers. So negative 2 times negative 6 is 12. N to the 6th times n to the 3rd, adding the exponents is n to the 9th. Y 5th times y squared is y to the 7th. To multiply these two partial answers, 12 has no coefficient to multiply with out here, so it remains 12. N 9th times n 3rd is n to the 12th. Y 7th times y 3rd is y to the 10th. Number 17, once again, the only power to a power is out here on the right-hand side. So I will leave the first parentheses alone for the time being. And this will become negative 3 to the 4th, a to the 12th, n to the 4th. Now, this is negative 3 raised to the 4th power. I'm multiplying that by another negative 3. So that's technically negative 3 to the 5th. This is 1 plus these 4 makes 5. A to the 3rd times a to the 12th becomes a to the 15th. N 4th times n 4th, n to the 8th. Now negative 3 to the 5th power is actually negative 243. So that's another way that you could possibly write that simplified expression. And last one here, number 18. I've got power to a power twice. Now the negative 3 in the front has nothing to do with either of those, so leave it alone for now. We multiply by 2 to the 4th, x to the 4th, times 4 squared, x to the 10th, y squared. Now, none of these bases match. I can't use any exponent rules to simplify them, but I can say that 4 squared is 16, 2 to the 4th is 16, and I'm going to multiply those times -3. So 16 times 16 is 256, times -3 is -768. X to the 4th times x to the 10th is x to the 14th. And then I have a y squared. All right, looking ahead here. This next set of problems, we simplify 5 to the 5th divided by 5 squared. Well, the rule for a quotient of powers is to subtract the exponents. So that's 5 to the 3rd. M to the 6th over m 4th, subtracting m squared. Here, now we have 2 powers in the numerator, 2 powers in the denominator. But I'm going to simplify them one at a time. The p's, p 5th over p squared, is p to the 3rd. And then n 4th over n to the 1st is n to the 3rd. Number 4, a squared over a to the 1st is a to the 1st, or just a. Number 5, x to the 5th over x to the 5th. Now 5 minus 5 is x to the 0, but anything to the 0 power is just 1. So 1, and then y to the 3rd over y to the 2nd is y to the 1st. So a simpler way to write 1y to the 1st would be simply y. Number 6. Now, these coefficients in front of the numerator and denominator have nothing to do with your exponent rules. That is simply a fraction that needs to be simplified. So -2 over 14 will simplify to -1/7. And then separately, we'll consider our quotient of powers. y7th over y5th, when we subtract, gives us y to the 2nd. Number 7, the x's will cancel, one on top, one on bottom. Y to the 6th over y to the 4th is y squared. Number 8, I need to apply the power to a power rule, but when I'm applying it to a fraction, that little exponent of 3 goes with everything in the numerator and everything in the denominator. So this becomes 2 to the 3rd, a to the 6th, b to the 3rd, over a to the 3rd. Now, can that be simplified further? Well, I have a's in both the numerator and denominator, so I use my quotient of powers rule. 6 minus 3 is 3, so this becomes 2 to the 3rd, a to the 3rd, b to the 3rd, or 8, a 3rd, b 3rd. Number 9. Again, the exponent applies to both the numerator and the denominator. So 4 to the 3rd, p to the 12th, q to the 12th, divided by 3 to the 3rd, p to the 6th, q to the 6th. When I simplify the p's and the q's, I have 4 to the 3rd, p 6th, q 6th, over 3 to the 3rd. Or if I multiplied out my 4's and my 3's, that's 64 p 6th, q 6th, over 27. Number 10. The exponent outside goes with everything in the parentheses, numerator and denominator. So 2 to the 4th, v to the 20th, w to the 12th, divided by v to the 16th, w to the 12th. The w to the 12th on both top and bottom can be canceled. Apply your quotient of products rule to the v's. I get 2 to the 4th, v to the 4th, or since 2 to the 4th is 16, 16v to the 4th. Number 11, 3 to the 4th, r to the 24th, s to the 12th, over 2 to the 4th, r to the 20th, s to the 4th. Okay, 3 to the 4th over 2 to the 4th, I can't use any rules to simplify that, so I'll leave that part alone. R to the 24th over r to the 20th, when I subtract, leaves me r to the 4th. S 12th over S 4th, subtracting gives me S 8th. Again, if I want to multiply out my 3's and my 2's, this is 81 r to the 4th, S to the 8th, over 16. And number 12 over here in the corner, I got r to the 7th over r to the 3rd, which is r to the 4th. I've got S 7th over S 3rd is S to the 4th. And t squared over t squared cancels. So r 4th, S 4th. One more little set here. Now, there are a couple ways to attack number 1. Probably the simplest is to just leave the negative exponent alone as it is right now and just subtract 2 minus negative 3 to get 2 to the 5th. Now, if working with subtracting negatives is a problem, an alternative here is to always take every negative exponent and make it positive before you even start the problem, before you start simplifying anything else. So that would change this into 2 squared. If this negative exponent needs to be made positive, it has to come to the numerator. So it would be times 2 to the positive 3, which is another way to get 2 to the 5th. Okay, if we use that method in number 2, bringing this up, it becomes m times m to the positive 4. So it's m 5th. Okay. This one, if we use the same property we just did in numbers 1 and 2 to make p to the negative 8th into a positive exponent, it would have to move to the denominator. Well, that would leave nothing on top, but it can never be a 0, or it won't turn into a 0. So that would become 1 over p to the 3rd times p to the 8th. So that's 1 over p to the 11th. Now, if we had to write that as an exponent, or as a power of p, another way to write that would be p to the negative 11th. Okay. In number 4, since both of these are negative exponents, they can just switch places and turn both of them positive. So b to the 5th in the numerator, b to the 4th in the denominator, which is, when we simplify, b to the 1st or b. Okay, and number 5, anything to the 0 power is 1. So since that entire expression in the numerator is raised to the 0, the whole numerator just becomes 1. In the denominator, the 4 has no exponent, so I'll leave it alone. But w to the negative 1st, I would move to the top and make it w to the 1st. Leave y squared where it sits. So this would be a fine answer. To look a little neater, it could be w over 4y squared. Number 6. If I use a power to a power first, that becomes a to the 4th, b to the 6th, over a to the negative 2, b to the negative 2. Well, we want to move those negative exponents out of the denominator to make them positive, so this goes up, this goes up. So this is a to the 4th, b to the 6th, times a positive 2, b positive 2, which I simplify my a's, a to the 6th, and the b's, b to the 8th. Number 7, since the y is raised to the 0 power, it just becomes 1. The x to the negative 2 I want to bring up into the numerator, so this becomes x 4th times x squared, x to the 6th. In number 8, the power to a power rule says apply these to everything in the parentheses. So 6 squared a to the negative 2, b to the second, over b to the 8th. That a to the negative second, to get it out of the numerator, make it positive, I need to bring it down to the denominator, so this becomes 6 squared is 36 b squared over a squared b to the 8th. Now, 2 minus 8, the exponents on the b's, 2 minus 8 is negative 6. So the next step here would say 36 b to the negative 6 over a squared. Now we usually like to have our answers with all positive exponents, so I need one more step to take these b's and move them to the denominator. So 36 over a squared b to the 6th. Now a little bit of shortcut here. When you are simplifying the b's, rather than see this in-between step where you did 2 minus 8 and got b to the negative 6th, I can just subtract, once they're all positives, I can subtract the large exponent minus the smaller exponent, 8 minus 2 is 6, and then just know that my answers, my b's that remain, will be written wherever the larger exponent was. Since my b to the 8th was in the denominator, my leftovers, my b to the 6th, is in the denominator. Okay, number 9. The exponent 2 goes with everything in that first parenthesis, so 3 squared, s squared, t squared. The u to the negative 4, I want to move down to the denominator, so u to the 4th. This s to the negative first, I'm going to move up in the numerator and make it positive. T squared is in the denominator, and u to the 7th. So what can I simplify here? In the numerator, I have s squared times s, so that's s to the 3rd, and I have a t squared. In the denominator here, I can put together these u to the 4th and u to the 7th to get u to the 11th, and then a t squared. I have t squared in the numerator and denominator, so those cancel. So I'm left with 3 squared s to the 3rd over u to the 11th, or 9s to the 3rd over u to the 11th. Okay, number 10, I have this negative first power in the denominator to apply to everything in those parentheses. So let me make that s to the negative 2nd, t to the negative 3rd. Now in the numerator, I already had some negative exponents, so if I bring those down, make it s to the positive 3rd, make this t to the positive 5th, I no longer have anything in the numerator right now. So again, that's never a 0, you make it 1. Now I can either simplify these t's and s's as they are in the denominator, s to the negative 2 times s to the 3rd, negative 2 plus 3 is s to the 1st, and t to the negative 3rd times t to the 5th, negative 3 plus 5 is t squared. Or I could have moved the s and t that had negative exponents, I could move them to the numerator and then simplify with the quotient of products rule. Number 11, everything is raised to the 0 power, so your answer is just 1. And here at number 12, I'm going to apply that negative 3 exponent in the numerator to everything inside those parentheses. So that's negative 2 to the 3rd, m to the negative 3, n to the negative 6th, all over 4 m to the negative 6th, n to the 4th. Okay? Now I do not need to move this negative 2 because it doesn't have a negative exponent. The number is negative. The base is negative. That's okay. If I want to, I can make that negative 2 times negative 2 times negative 2, which is negative 8. But then I'll move everything that has a negative exponent on it. So I'll move this m to the negative 3 down. Make it m to the 3rd. N to the negative 6th move down, n to the 6th. 4 can stay right where it is in the denominator. M to the negative 6th down in the denominator needs to go up, m 6th. N to the 4th down here is fine just where it is. It's already positive. Now what can I simplify further? This is negative 8 divided by 4, so negative 2. M to the 6th over m to the 3rd is m to the 3rd. And then these n's in the denominator, n6 times n to the 4th, is n to the 10th.